Okay, good morning and good afternoon or good evening, depending on when you listen to this slide presentation. My name is Victor and I'm going to be your anchor for this training. Okay, so this is the Cisco ITN, Introduction to Networking. This is the 5th module in the series, Number Systems. Yes. Yeah, we're trying to introduce you to networking, and it's good you understand some numberings. My first degree is mathematics, and this is more or less like a base 2 to 10, base 10 to 2 module. So nothing much here. We'll just run through it. Okay, so why do we need to learn number systems? Yes, binary, hexadecimal, decimal, base 10. Devices on our network communicate via binary, right? So, but the way we write our stuff, for instance, our IP addresses, we write them in base 10. So that's 0 to 9. So, but the way these PCs are going to understand stuff is in decimal places, zeros and ones. So that's why we need to also have some understanding about how to calculate numbers between decimals, binary, and hexadecimal systems. Not too much of a big issue. So binary number systems. So binary number systems consist of zeros and ones, like I said, decimals 0 through to 9. Hosts, servers, and network equipment use binary addressing to identify each other. So that's the only way these guys can communicate. They understand zeros and ones, elementary computer science. Each address is made up of 32 strings, right? That's why we say, or rather 32 bits. That's why we say IP version 4 is 32 bits. IP version 6 is 128 bits. And MAC address is 48 bits. So for IP version 4, which is 32 bits, you gotta split this guy into 4 piecemeal, and you have 8 bits per section, right? So each octet, which is 8, if we divide 32 by 4, you have 8. So each of these guy is 8 bits. Each of these guy is 8 bits. So if I type an IP address 192.168.8.1, each of them gets me 8 bits or 1 byte, separated by a dot. For ease of use by people, these dot notations is converted to dotted decimal. So the way we understand these things is to write them in our regular 192.168 whatever. Okay, so there's a video in your Cisco Learning Management System that tells you, that does some overview of some of these basic numberings, decimal places, and also binary. So if you don't have access to the Cisco LMS, you could inbox, you could send me a message. I'm going to let you in, and you can follow up with the course. You could take quiz, you could take your exam, you could get a digital badge, and you can add it to your online platforms as an accreditation for you having taken this course and being certified. So binary position rotation. So position rotation means that a digit represents different values depending on the position. Take for instance, when you say radix, radix is just a numbering system. It could be base 10, it could be base whatever. So if it is base 10 and I have 192.168.1, this last guy is going to take position 0, position 1, position 2, position 3. So you count from 0 backwards. Since it's base 10, if I'm going to calculate, I'm going to have 10 to 3, 10 to 2, 10 to 1, 10 to 0. Of course, 10 to 0 is going to give me 1. 10 to 1 is going to give me 1. 10 times 10 times 10 times 10 times 10. Up to 10 places, sorry, 10 times 10 in just that's 2 places, I get 100. 10 times 10 times 10, that is in 3 places, I get 1,000. So thousands position value, this is 1,000, this is 100, this is 10, and this is 1. By decimal numbers, I have 1, 2, 3, 4. So if I want to calculate, I times this by this, I get this. I times this by this, I get this. I times this by this, and I get this. So if you add them up, this is 1,230 and 4. So I have 1, 2, 3, 4 at the end of the day, 1,234. See how it works here. If I'm on base 2 decimal, or rather binary is zeros and 1, and I have up to position 7. So if I have to calculate, that's 2 times 2 times 2 times 2 times 2 in 7 places, 2 times 2 times 2 times 2 up to 6 places. So this is what I have. It's very straightforward mathematics. Then for position value binary, if I want to take this back to decimal, as in I want to take base 2 to decimal, that's how you do it. So you understand this is position 0, 1, 0, 1, 2, 3, 4, 5, 6, 7. So this is 7, right? Position 7, 1 to 8. So you start from 1 to 8 and go down, down, down till you get to 1. Of course, you can now start calculating times this by this, times this by this, times this by this, times this by this. Of course, you get that. Then you could now start adding up. If it's going to be 192. It's like saying, how do you convert 192 to binary? Right? Or this. So you're going to have 110, 11, 1, 2, 3, 4, 5, 6. Let me see that and see if we're correct. Yes, 1, 1, 2, 3, 4, 5, 6. So just a typical conversion of base 10 to base 2. Or if I want to say this to decimal, what do I have? Of course, I'm going to get 192, right? So this is it, 1, 1, then zeros in 6 places. So not much of a big deal there. This is just a chapter that has to do with numbering systems. So you want to get that, have an idea about that. Same thing here. If we're converting binary to decimal, if our IP address was 192.168.11.10, what does the system see? The system sees all of this gibberish here. Yeah. So since it's 7 positions, it's going to go from 1 to 8 up to 1. So start putting that all of this 1 times this, 1 times this, 1 times this, 1 times this, 1 times this. All of this guy is just for this guy, right? So this is the value here, represents this guy, 192. Then all of this guy here represents this guy. All of this guy here represents this guy. All of this guy here represents this guy. So it's like saying converting 192.168.11.10 192.168.11.10 to binary. Right? Still gets will I get something that's going to convert it to, for me, just straightforward? Okay, but I could just pick them one after the other. It's going to still give me same value. Yes, I get 192. I write that down to binary, like we did earlier on. I write that down. (168) to binary. I write that down. So I'm going to get this, which is equivalent to this. 1010 1000. 1010 1000. So just same thing. So we're going to get same thing if we do the manual mathematics. Okay, so decimal to binary conversion, same thing, just like we've done. So if I ask you a question, convert decimal 168 to binary. So how do you do that? The question is 168 greater than 128? The answer is yes. You enter 1 in position 1 to 8 and subtract this, you get this 40. Is 40 greater than 64? No. So this is decimal, right? So it's very literal. Is this greater than this? No, they are all equal. So we're just trying to compare if we have this in decimal and if we have it in binary, whichever way, you're still going to have same results. So that's why 168, for instance, is written like this in binary. If you want to do the conversion, how do you do the conversion? That's this 168. You just put this, since it's 6 digits, since it's an octet, to have 0, 1, 2, 3, 4, 5, 6, 7. So 0, 1, 2, 3, 4, 5, 6, 7. So you have 8 items. So you start from 1 to 8. So 1 to 8. So you now start saying, okay, if I times 1 by this, I have this. If I times, okay, this is conversion from what's it called? From binary to decimal, right? Okay, let's look for just a moment. Okay, yeah, so this is decimals back to binary. So the point is that routers and computers only understand binary, like I've said earlier on. Why humans work in decimals, it's important for you to gain a thorough understanding of these two numbering systems and how they are used in networking. Hexadecimal. So hexadecimal is from 0 to 9 and letters A to F. Like coloring, if you do graphics, if you do branding, if you use either Figma, Photoshop, Illustrator, and all of those graphics stuff, you see that the RGB color code can also be converted to hexadecimal. So it's always from 0 to 9 and also from A to F. So I think that's what our MAC address use. Okay, yes, it's here. Hexadecimal is used to represent IP version 6 address and MAC addresses. Yes, because if you try to get your MAC address, just a moment. So if you try to get your MAC address, so you say ipconfig, for instance, you say all, so you could get everything. So you see, this is a physical address like I spoke about in the previous module. So you see, you're not going to get more than F. You have A, B, C, D, E, F. The next letter after that is G. So you're not going to get anything after that. You're not going to get anything, of course, after 9. So after 9, you get back to 0. So that is how the MAC address is being addressed. Okay. So let's try it on with that. So, like I said, IP version 6 addresses are 128 bits in length. So every 4 bits is represented by a single hexadecimal unit. So that makes up a total of 32 hexadecimal values. So you have 1, 2, 3, 4, 5, 6, 7, 8, right? But the point is that, for instance, for IP version 6, it's slightly different the way the numbering is done. So because I think in this CCNA 1 or CCNA 2, we're going to see how it can be compressed at times, the different ways you can compress IP version 6. This is a typical IP version 6. There's what we call ANDing. So like, for instance, you have here, you see it's not up to 8. Yet it's not up to 8. This is 1, 2, 3, 4, 5, 6, 7, 8, right? So at times it's not up to 8. When you see your IP version 6 address, what happens is that if I have 0, 0, 0, that's zeros in 4 places, you just use a double a colon to indicate that, and that's how at times you have the IP version 6 address compressed, or what we call the leading zeros. So look at this one, it's shorter. See, it's shorter. Look at this one, it's longer. So I think maybe in this course or in the CCNA too, we're going to look at how IP addresses are being addressed and how they are compressed and the rest of it. Okay. So converting between hexadecimal and numbering system. So there's a video in your Cisco Learning Management System that addresses that. So please log into the platform and watch that very short video that tells you how to do conversion back and forth. Okay, so follow the steps listed to convert decimal numbers to hexadecimal. Convert the decimal numbers to 8-bit binary strings. For example, you could convert 168 into hex using the 3-step process. So 168 in binary is this. This in 2 groups of 4 digits is this and this. So if I split this into 2, I get this. This is hex A and this is hex 8. So 168 is A8, right? So this part is A, then this part is 8. So there's nothing much to try to say you want to cram or you want to do whatever. Very basic things you should understand is that, one, computers just understand binaries. There are some components like your MAC address. It's going to be in hexadecimal. Then, but we humans, we're always going to be using decimals to do all of our writings. That's the end of this module. A few things we've learned. A binary is base 2 numbering system. It consists of zeros and ones. Decimals, which we normally use, is 0s to 9. Binary is what hosts, servers, and network equipment use to identify each other. Hexadecimal is base 16 numbering system that consists of 0s to 9 and A to F. That's why it's called 16. 0, 1, 2, 3, 4, 5, up to 9. So this is 10. 0 to 9 is 10 items. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 10 items. A to F is 6 items. A, B, C, D, E, F. So 10 plus 6, you get 16. That's why it's called 16 numbering system. So we talk about binary, decimal, then hexadecimal. That is base 2, base 2, base 10, base 16, right? I think that is all. Thank you very much. See you in the next module. Don't forget to like, to subscribe, to share. If you don't have access to the Cisco LMS, do inbox so that you could watch some of the extra videos, do your quiz, do your assignments, do the exam, and get a digital badge from Cisco.